So welcome back, folks. So we talked about combining variances, right? And we see that how when we combine variances, the eventual volatility is actually lower than individual variances, right? And individual standard deviation, right? So you cannot add standard deviations directly, but you can always add variances, right? So now we are going to take that discussion back to uh, to money, right? To building a good portfolio, right? And so 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 say you have $100 to invest, okay? And we're going to build a two asset portfolio first, okay? And you've decided to deploy it into a two asset. One is large US stocks and the other one is bonds, right? And now that now the fact that your goal is to diversify means that you will invest some of that $100 into one category and the remaining into the other category, right? So technically, the weight you assign to each asset class has to add up to one, right? Because that's you're gonna split that $100 into two pieces, but the percentage of what you assign to each piece has to add up to one, right? So let's say let's quantify x1 to be the random variable which sort of quantifies the returns associated with large company stocks, and x2 is the random variable which quantifies return on bonds, right? So the expected return of this two asset class portfolio, which is the mean return, is nothing different than what we have done in the past, except that now you have this weight components, right? So yeah, it might look a little bit complicated, but ultimately what you're doing is you are calculating the average return based on the weight you put in, based on the amount of money you put into that asset class, right? So if you put in like say 60% in large US stocks and 40% in bonds, then this will be 0.6 times x1. This one will be 0.4 times x2, and you're going to take that weight and then average it out, right? And that's what you're doing, right? So it's W1 by expected return. So 0.6 times the expected mean return of large company US stocks versus bonds, right? And this is what we have here. Portfolio variance is, as we have seen, this formula gets a little bit more involved, but it's again the same thing. We have done that in the past, except that now you have this weight component. So the eventual, if you work down this thing, if you want to work down this thing, and if you get to that bottom, you will see that it sort of reverts to this form, right? So you have the covariance term, which we know is going to be there when you combine two variances, right? Sometimes ideally you want, in order to minimize standard deviation, we have seen that, right? In order to minimize volatility, you want this component to be negative, right? As negative as possible. That means what that technically means, if you really look at it from the perspective of asset classes, you want one. Let's say you own two stocks, right? And if one company goes up, the other company goes down. Hopefully it doesn't go to zero, but let's say you want something to zig while the other one zags, right? So basically it's zigging and zagging approach, which will cause your covariance term to be negative, which will then cause your overall variance to be smaller, right? And that's what you want, right? Basically what you're trying to do is you're trying to optimize the mean and variance, right? And this is the whole thing, mean variance optimization, right? And we can repeat that same exercise with a three asset portfolio and so, right? But there's no point in doing it by hand when you can use a little bit of matrix algebra, right? You don't have to use it. You don't have to sort of even you can just walk along, but that is, in this entire course you will not be using matrix algebra, but this is something you probably would have done in some high school math classes, right? If you ever had a chance to do that, right? But before that, so how do we get to those optimal weights, right? Like, how do you know that you want to put 0.62% in this and 0.38% in the next asset class, right? If it's a two asset class portfolio, right? And by optimal, we mean we want something which has the least amount of volatility and the highest level of return, right? That's what we define optimal, right? So you would not want to pick a portfolio which is less optimal because it doesn't make sense, right? Um, um, so basically, you want to have a portfolio which lies on the efficient frontier. We talked about that, okay? But we don't know that, right? Because we are looking back in historical data and we're trying to sort of come up with a portfolio which sort of makes sense based on that optimality, right? And as we will see later on, even that is not like a foolproof approach because we are looking back in data, right? And a lot of the times when we are dealing with market data or any types of data where you're trying to sort of fit a model, because that's what we are trying to do, right? So we are trying to sort of fit a model to data and sort of coming up with a theory, right? So, but the theory sort of makes sense, but you have to be careful whenever you are fitting a model to a data set, right? I think there was a story I came across where I think it was one of the presidents, Abraham Lincoln, I think, and he was sort of projecting based on like a few decades worth of population data. He was trying to project that by the time in 60-70 years the population will be this, okay? All he was doing is extrapolating based on what has happened in the past to the future, but in reality he was way off based on what he thought would happen versus what actually happened, right? So that's always the problem with data. And when you try to fit data to when I try to fit model to a data, you sometimes can go astray. But you have to sort of use that, but you also have to keep that in mind that it better be justifiable, right? And especially in this case where your money is involved, right? You want to sort of create a portfolio that you can stick with, right? Okay. So what we're going to do is we're going to run through different combinations. So we have 7 different asset classes, right? We started out with, right? That small data set we talked about, right? So we're going to sort of divide this thing into 10% increment, right? So each. So we're going to assign, and this is what a portfolio combination looks like, right? Let's look at it. It's coming. Okay. So these are all the different portfolio combinations. It all adds up to 1, which is what we want, right? So in the first portfolio, this is 1, 1. You have 100% in W1, which is the asset class 1, and nothing in the red. Then the second portfolio is 0.9 in that, 0.1, 0.8, 0.2, 0.3, and we repeat that 7,658 times, okay? And that's the possible combination of portfolios with 10% increment, okay? So once we have those portfolios, right, and so and for each of those portfolios, you're going to calculate the mean return, right? So W11, for example, it's the weight assigned in portfolio 1 to asset class 1, and that's your return for that asset class. Portfolio assigned portfolio 1 asset class 2, portfolio 1 asset class 3. Similarly, you do that for portfolio 2 and so on, right, for 7,658 times, right? Now you could do it one by one. You can write a loop, and that's why we introduce matrix algebra. You don't have to do it. As I said, this course is like completely open-ended. It's up to you to sort of see as to how far you want to extend your understanding of what is going on. You can go as deep as you want. You can spend like 6 months on matrix algebra if you want, and there are lots of applications to that. So basically all it does, it allows you to sort of so you'll be dealing with data. You know what spreadsheets are, right? Spreadsheets are basically all the Excel stuff you work on. Data frames you will be learning in this course, right? Matrices are just another form of representing the same the same data set but without row and column identifiers. What they help you do is they help you do this kind of calculations very quick, right? So this is not as big a data set, but sometimes when you're dealing with big data, you will come across millions of rows, right? You could have a situation like that, and that's where you want to sort of utilize some of these tools. Okay, these are all techniques. Okay, these are not these are just shortcuts to arriving at the same thing. Instead of repeating this thing like this, right, and doing it one at a time, you just do that. So this is for a 2 asset portfolio. This is one portfolio. You have 60% here and say 40% here. Do this math and you get this. Okay, so you can just quickly put it in, and this is how you calculate the variance of that portfolio. Okay, and you have 2 terms. Yeah, so instead of spending a lot more time on it, it's just the way you do it, right? This is your covariance matrix. You have the variance and then covariance on the diagonal terms, right? And you and why these 2 times? If you sort of spread that out, because you want to get to this formula, this way. This is the way you calculate variance. You want to get there, right? And that's why you have to do it 2 times. Weight. One is the transpose of that weight matrix. Okay. Don't worry about what it means, but ultimately you want to get to that, and this is how you start out with, and you do the matrix math and you get there. Okay. And so similarly, so this was a 2 asset class portfolio. Now when you have a rows and rows of portfolio matrix, which is portfolio combinations, which is what you're going to try. You want to do with 1 portfolio, 2 portfolio, 3 portfolio, all in once. Okay, instead of doing it one at a time, you want to do it all at once, and that's what we are doing here. Okay, so this is say 2 different portfolios with different combinations in each asset class. Okay, so this is portfolio 1, this row is for portfolio 1, this row is for portfolio 2. Here we were only dealing with 1 portfolio. See, we assigned 1 out of that 100%, we assign 40% to this and 60% to that, right? Here you're doing 2 portfolios at a time. Okay, because you want to run it efficiently, you're going to be doing the same logic for 7,658 portfolios. Okay, so for 2 portfolios, same thing what you do for 1 portfolio, because there are 2 asset classes. You're just going to do it 2 times. Okay, portfolio 1 asset class 1, portfolio 1 asset class 2, portfolio 2 asset class 1, portfolio 2 asset class 2, R1 R2, and you can just do a quick comment, and you will have like an entire column of this thing for different portfolio combinations. 1 2 3 4 5 6 7,658 times. Okay, same thing you will be doing for variance. You will have portfolio 1, portfolio 2, portfolio 3, and a variance column 7,658 times. Okay, and that's what we are doing, right? So the top row is the variance for portfolio 1, but this thing is portfolio for variance 2. Variance for portfolio 2, and you do that for 7,658 times.